As we make our application for the travel agency grow, we add functionalities and make changes to things that we had implemented before. However, something we missed was testing the application again after making changes to make sure that what was already functioning continues to work correctly. These sorts of tasks may become quite tedious with large applications, and mostly the fact of repeating tests of things already tested. Although necessary, it's very boring to do. GeneXus helps us in the automation of such tests with the GXTest tool. GXTest enables us to define tests that are later automatically reproduced, as if it were an individual entering data and verifying that the system functions correctly. We'll see this with an example. Suppose that, for the business of our travel agency, working with attractions, that is, the possibility of creating, modifying, and deleting attractions, is fundamental. And if we have an error in that process, that would have a great impact on our business. So, once this process has been programmed, and when we have validated that it's actually functioning properly, we'll want to capture that validation so that it may be done automatically in the future as a form of regression testing. The first thing we need to automate our tests is the GX recorder. This tool enables us to capture the manual execution to then take it to GeneXus. The GXTest recorder is an extension of Google Chrome that's free and can be downloaded from Chrome Store. With the extension installed, we'll have it available in Chrome like other extensions that we may have. After installing the extension, we can execute it from the Chrome toolbar. And when we open the recorder, we press the camera button to start recording. With the recorder active, we execute the app as we usually do, in the same way we would do it to validate this manually. For example, we'll start by clicking on the Insert button to add a new attraction. And note the pop-up in the lower right corner with a message indicating that the action we've just executed was captured by the recorder. This will happen for every action that we execute. Now we'll create a new attraction with an existing name in a country that already exists, and we expect a validation stating an error for that. We'll then indicate that we want that validation to be captured. And we say that we expect this text to appear here, so we create an assert text. When we create that assert, we're stating that we expect this error message to appear. That is, if we create an attraction with the name Centenario Stadium for the country Uruguay, and we do not get this error message, then the test would be failing. Now we go on with our test, indicating that if we state a different name, then we expect the attraction to be recorded. We'll enter the values for this new attraction that we're creating, and we confirm. If we look at the recorder, we'll see each action we executed, as well as the points where we clicked, and the spots where we wrote a value, and so on. This is the test script that will be automatically executed later. Moving on with our test, we'll now validate that the attraction for which we'll search has been created. And we'll do a new assert, indicating that we expect this value to appear here. Now we'll modify it. Because our test is a full cycle, we want to make the entry, then modify, and also delete. We'll change the name to Estadio Centenario 3. And we confirm. And now we'll search for Estadio Centenario 3, and again we do an assert indicating that we expect this value to appear. Because if everything went okay and the addition was possible, then the name Estadio Centenario 3 would have to appear here. In the end, we'll delete it. And we will also do an assert to make sure that the confirmation message appears. Then we confirm to complete the full cycle of our test. Once we've completed the test, we turn the recorder off so as to finalize the capture, and now we'll have our test script written here. We can save this script and execute it from here as many times as we want. What we'll do now is click on the play button so that the test is reproduced as we expect. As the script is executed, we can see that steps are shown in green when the execution has been successful. That is, when we've been able to click on the control expected, and when we were able to enter the value expected, and the asserts are actually taking place. From the recorder, in addition to recording and executing tests, we can also edit the script, deleting unnecessary steps. In executing the test, we could have made unnecessary clicks, and we can delete those, and we can also add further validations. Once we're satisfied with our test, validating what we expect, we're then ready to take our test to GeneXus. Even when the automatic integration is not done yet, it's very simple to take the test to our KB. What we have to do is export it by means of a click on the download button. This will generate a script, a text file, that's GeneXus code. From here, we'll copy the code, and then we paste it on a special object in GeneXus. We then go to the KB and create a new object of the UI test type with the name test attractions. And there we paste the code captured in the recorder. The UI test object is a new object in this version of GeneXus that requires the GXTest license to be used. What's interesting about having the tests within the KB is that they're then part of our knowledge base, and therefore we'll be able to do test versioning in addition to sharing and extending the tests. This new object uses functions of GXTest that enable us to control the browser using different commands. For example, opening the browser in a given URL, selecting or activating different controls, making validations, that is to say asserts, on screen, and so on. The recorder makes the task easier for us by writing the code automatically. But once in GeneXus, we can extend the test and perhaps feed the data to be tested from a data provider, or add validations to the database. For example, we could verify that the record actually does not exist in the database after we delete it on screen, for which we did not include any assert in the test, so we could add an assert here, validating that the record does not exist in the database. We can execute our script in the same way as we executed the unit test, with a right click and selecting the Run This Test option, or also from the Test Explorer selecting the interface test. We can also change the browser where our tests are executed. We can specify that we want to use Firefox instead of Chrome, which is the default browser, and we can execute the test from here. The idea is not to execute the tests from the GeneXus IDE, but rather execute it once our series of tests are built and are functioning locally, in some other place, in order to avoid having all browsers and all operating systems installed in our computer where we want the testing. It's possible to instruct GXTest that we want to execute the tests in the cloud, for example in a tool like SauceLab, which is a possible cloud for running functional tests on different operating systems and browsers. You can find further information on this in our wiki, in the URL shown on screen. These kinds of interface tests that we've just seen are widely used for validating whole functional cycles of those things in our business that should not fail. In sum, we want to make sure that, with these tests, that when a user goes through the happy path, or rides on the route's yellow line, meaning that he encounters nothing strange and he stays on his way using the critical functionality of our business, we'll know that the flow will be successful and no errors will be encountered. These are the flows that we'll automate first, because they're the most important flows, and what we want to be sure of is that it'll never break when we introduce changes to the application. So far, we've seen how a test is made automatic. However, we were executing it manually. What's interesting in these tests is that their execution should occur automatically, which means that the test execution will be part of our automated process for continued integration with Jenkins. We won't see the details in this course, but just to mention it, Jenkins is a continued integration engine that enables us to automate the execution of the various steps that are part of the setup and a build of our application. The typical example of a pipeline in Jenkins, that is, a sequence of steps that we must execute when setting up a new build of our app, is the following. In the first step, an update is done in the KB where we set up the application. This means that we bring, from GeneXus server, all the objects that have been modified since the last update. In the second step, a build is done in GeneXus, meaning that the objects with changes that were just downloaded from GeneXus server are reorganized, specified, and compiled. In step 3, the unit tests are executed. If everything's okay, the UI tests are then executed in the end. After all this, and depending on the test degree of coverage, the application's build will be ready for release to production, or for a tester to manually perform the test of the new functionality. The idea is that when the tester appears, we already know, at least, that all the regression tests are okay, and so are all the unit tests of the new functionality. So what remains is to do the integration test, or the full user cycle for the new functionality to be released. You can find further information on continued integration and on automatic test execution in our wiki. GXTest is a great ally that aids us in making our app reliable while reducing the test time because it makes the generation and execution of automatic tests easy. In addition to this, it's also a fundamental tool in the automations required for a continued integration process, enabling us to build software in an agile manner, preserving quality aspects. For further information on this, go to the URL shown on screen.